Good morning, dear students. This is Karan, I am your maths teacher, and today we'll be discussing exercise 1C, question number 8. If z is inversely proportional to x and z is 5 when x is 7, find the value of x when z is 70. So we know that z is inversely proportional to x, so we can write it as z multiplied by x is equals to k. So z times x is zx. So k will be z times x. Now we are going to replace z with 5 and x with 7. So you're going to get the value of k is 35. Now we are going to make a connecting equation, and we always make a connecting equation with respect to what we need to find in the next step. So we have to find the value of x. So we are going to make a connecting equation with respect to x. So x will be k upon z. So we are going to take this z as denominator on the other side. Replace the value of k with 35. So this is the connecting equation. That is x is equal to 35 divided by z. Now, we can use this connecting equation and find the value of x when z is 70. So replace z with 70. So you're going to get half or 0.5. Now with this, you can pause the video and solve question number 9 by yourself and then resume the video. Let's proceed to the next question. Exercise 1C, question number 10. If y is inversely proportional to x, copy and complete the table. Here you can see this block here, which has both the value of x and y. X is 3 and y is 4. And we know that y is inversely proportional to x. That means y multiplied by x is k. And so we need to find these empty blanks here, boxes. So we need to make two connecting equations, one for x and one for y. Anyways, we are going to replace the value of x from here, which is 3, and y, which is 4. So k will be 12. And now from here, we are going to make two connecting equations, one for x and one for y. So for x, the connecting equation will be k upon y, replace k with 12. So in order to find the value of x, we are going to use the connecting equation 12 upon y. And to find the value of y, we are going to use this connecting equation 12 upon x. Now let's see. If y is 24, how much will be x? So let's use the connecting equation of x. X is k upon y. K is 12, y is 24. So the value of x is half or 0.5. Now, if y is 1.5, how much will be x? Again, x is k upon y. K is 12 and y is 1.5 from here. So value of x will be 8. So you can write 8 here. Now, if x is 2, how much will be y? Now connecting equation of y is equals to k upon x, and k is 12 and x is 2 from here. So the value of y will be 6. If x is 2.5, how much is y? Connecting equation, y is equals to k upon x. K is 12 and x is 2.5. So y is 4.8. Now you can pause the video, and just like this, you have got another grade in question number 10 part B, and you can attempt it yourself by looking at this part of the question. Once done, resume the video. Let's go to the next question. Exercise 1C, question number 11. The frequency f kilohertz of a radio wave is inversely proportional to its wavelength lambda m. M is meters, since it is the length. The frequency of a radio wave that has a wavelength of 3000 meters is 100 kilohertz. You have to find two things. The frequency of a radio wave that has a wavelength of 500 meters, and then the wavelength of a radio wave that has a frequency of 800 kilohertz. Now, we know that frequency is inversely proportional to wavelength. Okay, so frequency multiplied by wavelength is equals to K. So frequency is F, wavelength is lambda, is equals to K. So let's replace the value of F and lambda. So F is 100 from here, and wavelength is 3000. So that gives us the value of K as 300,000. Now, from here, we are going to make two connecting equations, one for frequency and the other one was for wavelength. So if you have to find wavelength, lambda will be K upon F, where K is 300,000. And if you want to find F, you have to divide K with lambda, that is wavelength, where K is 300,000. Now, if the wavelength is 500 meters, how much is the frequency? So you have to find F. So F is K upon wavelength, which is lambda. Now K is this 300,000 and value of wavelength is 500. So 300,000 upon 500 give you 600 kilohertz. Second part of the question is you have to find the wavelength when frequency is 800 kilohertz. So wavelength is K upon F, and K is 300,000. The value of F is 800. So the wavelength will be 375 meters. Once done, solve question number 12 by yourself. So this was the lesson for today, and I hope that you have understood the lesson. With this, we'll complete exercise 1C, and in the next class, we'll be starting exercise 1D. So hope to see you tomorrow.